Hey guys, here, what's up, it's your man again, it's your guy again, Hamish, I'm trying to Ubuntu. Hey guys, what's up, you know, it's your man again, it's your boy again here, I'm trying to Ubuntu Academy. So we have a question here, man. Before we get started, man, you know, I think I've got very important basically here to say Chicago, Southside, Old Block, Glenwood, so gang violence, man. People who have no idea there's a lot of gang violence. Southside Chicago's not everywhere, it's some of the place. But it's gonna be, I've got a friend of mine, very close friends, man. He lost about 22 friends. You see, these are the people, his friends, 22 friends. So you can imagine how it's going down there, man. So some gang violence. So Boko Haram, also Al Shabaab, so killing innocent people, man. You know, in Africa, Boko Haram, in Nigeria, in Al Shabaab, also Somalia, some killing innocent people. So let's pray for Libya, Syria, and Chicago. You know what's happening in Syria, man. In Chicago. Let's get to the question. Say, Tamandi, what the the following, and simplify if it's possible. So, look, man, this is a product rule. You know why we say product rule? Because we got face function and the second function. This is a face function right here, and this is second function. So let's see how we can differentiate these two things. So this is a product rule. So how we do why you say product rule? Because I got product of two functions. The first function x squared, the second arcSin 1 minus z. Let's see what we can do. So if you have a product rule, that's how you do it. For product rule, use a very simple formula. You say f, let's assume this is f, and g. When you differentiate, means when you differentiate f and g means this and this when you differentiate. So we assume this is f and this is g. So meaning, if it's a product rule, you put the face on constant. When you put this, means you differentiate. Mean the face on can be constant, and if this is constant, then we have to differentiate the second one. Then we plus for product rule, and now we're gonna do vice versa. Means now if g is constant, and then we have to differentiate what? F. So we're gonna have to follow this to solve this equation. So it's easy. Okay, let's go. So what we're gonna do shows me. So I'm gonna assume this is x. You see, this is x. Or if you don't want to do that, you could do like this. You say, okay, so f and g dash means when you derivate these two functions, in other way means you find dy and x. So let me say this f and g means dy dx equal. So the face on f is constant. So I'm gonna put my f constant. What is f? X squared. And then I'm gonna differentiate the second one. So say d dx. What is the second one? It's a second function right here, which is arcSin. So it's real option, man. ArcSin, however you prefer to do. 1 minus x. And then it's gonna be plus g. What is a g? Excuse me. This is our g now is gonna be constant, and then we're gonna differentiate this one right here. So I'm gonna say, okay, so my g, let me try to squeeze this so I can get a place here, I can get the face. So I'm saying, so now, so plus sign, excuse me. Oh, apologize. So bracket, and then we say 2-minute bracket here, man. Come on. Okay, so now close bracket, and then we close the bigger bracket. This and this, that one. Then we say plus, and now g. What is a g? G meaning the second. So this is going to be constant now. G. What is the g? The second one. So arc sine 1 minus x, and then we're going to differentiate f. What is the f? F is x squared. So we're going to say d dx. Excuse me. So I'm going to raise this and now move further a little bit so that you can see, so that you can get a space here to solve our equation. We're going to differentiate now x squared. Okay. So let me rewrite my equation again. So one minute confusion, like where did you get the equation from? So the equation, it was y equal to x squared arcSin 1 minus x. 1 minus. Okay, so let's go. So now, excuse me, let's differentiate. It's easy, man. So first of all, man, let me show you how to differentiate arcSin. So for arcSin, when you differentiate, for example, before we get started for that question, excuse me, if somebody give you, for example, what is arcSin? ArcSin, when you say arcSin, or arc of any trigonometric, let's say arcSin f of x. Arc meaning sine inverse. This is the same as saying sine inverse of f of x. It's the same thing. That's what arcSin meaning. When you say sine inverse and arc, it's the same thing. If somebody say arctan, let's say of g of x. What does that mean? This same as say tan inverse of g of x. So it's actually the same thing. So so let's go solve the question now. So how will we differentiate the arcSin now? Okay. So differentiate arcSin. Let's say somebody say I'm gonna go back there. Somebody say differentiate this. Okay. So somebody say, for example, differentiate arcSin of let's say p of x. So when you differentiate arcSin, it's easy. So what you do, differentiate what is in here. So when you differentiate p of x, you're going to get p dash x. You put it on top. Differentiate what is in front of sine. And we're going to get p dash x. And then we're going to say, you put your square root. And then always you take 1, you square. See, you take 1 square. You know what we say, 1 square? So you say 1 square, and then you minus the square of this function. So this is p x squared. But we're going to check more example, right? Not all the time it has to be 1. P x squared. That's how you get it, which is easy. See, so that's how you differentiate arcSin. Example: somebody give you d dx. Say arcSin. Let's say arcSin e of x squared. Let's say e of x squared, something like this. So let's say differentiate. So what I'm gonna do, what did I say? You have to take this function here and differentiate, and then write the answer on top. So when you differentiate e of x squared, means look, it's e of x squared. How we differentiate this? You differentiate the power, and then you're gonna get 2x. It's gonna be 2x, and then you write it the way how it is. So e x squared. So when you differentiate e x squared, you get 2x e x squared. So what I'm going to do, that answer I'm going to have to write on top. Look, we differentiate this, the answer I'm going to write on top. So I'm going to write on top here, 2x e x squared, and then over square root, excuse me, square root of what of 1 minus, I take my function, then I square. What is my function? My function is this. I'm going to have to square. So it's e x squared, and then what you do, you square. So that's easy, man. So that's how you, excuse me, that's how you get, that's how you differentiate arctan or sine inverse. Arcsin, my apologies, I was meant to say arcsin. That's how you differentiate arcsin, and that's how you do sine inverse. So let's go back to our equation. It's easy. So I'm gonna raise this part here. So I'll go back again to our equation. I'm gonna raise everybody. So you hear me? So let's go. That's how it is, man. So let's go. So now how we're gonna do this one is easy. So dy, I got my dy dx equal x. Alright, so what we're gonna do right now, so excuse me, so this is gonna be constant, and then we're gonna differentiate this one. So we know how to differentiate right now. So what we're gonna do, we're gonna take this function here, which is in front of the sine, we differentiate. So when we differentiate, look, 1 minus x, we have to differentiate. So in other way, I would say, okay, so I would say this, let me say dx of this function, which is 1 minus x, and then we say over, and then we write. So we over, excuse me, we're gonna say over, and then we have a square root, and they say 1 square minus, excuse me, 1 square minus, and then we're gonna take that function right there, 1 minus x, and then what we're gonna do, we're gonna square. Excuse me. But where that one comes from, you know, somebody may say, where that one comes from? You see what I'm saying? The one comes from here. If there's other number here, it's going to be another sort here. See what I'm saying? So you're going to say 1 square. See what I'm saying? So that's 1 square. Okay, I'm going to show you more example at a time, but that's going to be 1 square. They say minus that function square. Okay, and then, so we're going to say plus, now we come this side, this is constant, then we differentiate x squared. When you differentiate x squared, you're going to get 2x. So this is going to be 2x. So here we're going to write arcSin as a constant, arcSin, and then we say 1 minus x. When you differentiate x squared, we get 2x. So most of the time I prefer that answer 2x, I'm going to write here 2x. I think it's going to make more good sense, so 2x. So this is what we have. So what we're going to do now, excuse me. So I can differentiate as well this one here. So this is going to give me negative x. So it's okay. So dy dx, dy dx equal, when you differentiate this one, this is constant number. So when you differentiate 1, you get 0. And when you differentiate negative x, look, this is power, because when there's no power, it means power 1. So 1 is going to come back, constant is 0, so 0, so it's going to be 0. The minus. This one is going to come back, it's going to be 1, and then it's going to be x. Power minus 1 equal to 0. So we have a negative 1 times 1, because the number 0 equal to 1, it's going to be just 1, so negative 1. Okay, so now on top, we're going to have a negative 1. And at the bottom here, we're going to have a 1 squared is 1 minus x squared. And there you see, plus 2x, and this is going to be arcSin, arcSin 1 minus x. And the question is finished, so it's the amount of normal simplification. So, all right, so now we say I can simplify this one, right? I can simplify. You know what I'm saying? So then after that, just for go 2x here. So there's an x squared, excuse me, it's not 2x, it's x squared. So we have an x squared here. So then after that, it's easy, man. The question is finished. So I'm gonna start with this one first, because this is a positive and then negative after. So it's okay. So this, let me say, I can just raise this one, raise some space here, and it's okay. So now I'm gonna start with this. This is, let me say, this equal to. Let me start with the positive face and the negative come after. So I'll start with the negative positive face, which is arcSin 1 minus x, and then this is negative is going to come after. I prefer to do that most of the time, but it's not something must, but you know, that's my preference. And then 1 minus x squared. So then we're going to say dy dx equal, so that's what I have. So I can simplify this one. 1 minus x squared. 1 minus x squared. So it's 1 minus x squared. So this, let me say 1, and then, okay, this will be 1 minus 2x plus x squared. So 1 minus 1 plus 2x minus x squared. This and this cancel, so we have 2x minus x. 2x minus x squared. 2x minus x squared. And then you can take out x here. X out, so it's 2 minus x. 2 minus x. So I'm not going to write this anymore. See what I'm saying? So I'm going to say I have a 2x, means I'm not going to write this again, because I know the benefit. So I say 2x is 2x. arcSin. And I got my 1 minus x squared. And then that's equal to, so let me say 2x minus x squared, 2x minus x, or you can write the last one, whichever. Either you write these or these are the same thing. Okay, so 2x minus x squared. Okay, so, or whichever, you can write this. Okay, let's go step by step. I'm going to write this one first. Okay, so this is a fraction, normal fraction. So this is over 1. I want to write in the same common denominator. It's not something must, it's optional, right? So, but the question is done. You can leave them how it is. So it's okay. So this is, let me say, okay, so let me find the common denominator. Means this multiply this side, like this side, and this is the same common. It's no mass, but the question. Okay, let me leave like that. It's done, man. I don't even want to waste a lot of time. So now say arcSin 1 minus x squared. Trying to play around here, man. And this is going to be x 2 minus x. 2 minus x. Done. So if you want, you can write in a single denominator, but the question is done. It's done here. Take this one here and that one there, and then single denominator. So dy dx. I think I forgot something here. Excuse me. X squared. X squared. Yeah, you know, I didn't forget anything. So now this one here, come here. So it's gonna be 2x arc. This one first. And then 2x arcSin 1 minus x, and then minus 1 times that one is that one, x squared, and then you can write in a single denominator, which is this and that one, x, normal fraction, like how you solve fraction. Done. So that's the end of the equation. So if you FaceTime with my channel, just make sure you share with other people. You know, there's a lot of people out there, you know what I'm saying, they're looking for a solution for this equation, and you can share my channel with other people that you think, you know, who might need to learn, you know, the optimal methodology and optimal solution for their problem. So, like I say, man, don't forget to pray for Libya, Syria, Chicago, you know, South, especially Southside. There's a lot of things going on, man. Thank you so much for your time. Leave the comments, and if you're FaceTime my channel, make sure you subscribe my channel. Share with other people. Thanks so much, man. I appreciate it, man. Thank you so much. I appreciate it.